What specific problem does the new method aim to solve in long context language modeling?
The new method aims to solve the problem of how long context language models can effectively utilize information at arbitrary locations within the input. Specifically, the method focuses on detecting and understanding retrieval heads within the transformer architecture, which are responsible for implementing a conditional copy-paste algorithm to retrieve relevant tokens from the input and redirect them to the output. By identifying and analyzing these retrieval heads, the method aims to address the challenge of ensuring that the model can accurately retrieve specific information from a long context, such as in the needle-in-a-haystack test, where the model is required to precisely locate and extract a short sentence, the needle, within a lengthy context, the haystack. The activation of retrieval heads determines whether the model produces factual outputs or hallucinated ones, highlighting the importance of these heads in enabling the model to faithfully represent the input information. Ultimately, the method seeks to enhance the model's ability to perform tasks that involve interleaving retrieval and reasoning in a multi-step fashion by shedding light on the mechanism through which retrieval heads facilitate information retrieval and accurate output generation in long context language modeling scenarios.
How does the proposed method of detecting retrieval heads work, and what is the retrieval score used for?
The proposed method of detecting retrieval heads works by introducing a retrieval score to measure the frequency of a head's copy-paste behavior during autoregressive decoding. The retrieval score is used to determine which attention head is implementing the retrieval algorithm. During autoregressive decoding, the current token being generated is denoted as W, and the attention scores of a head are denoted as bold symbol A in R _VERTA_XVERT. An attention head is considered to be copying and pasting a token from the needle to the output sentence if it satisfies two criteria. 1. The current token W is a token within the needle sentence, and 2. The input token that receives the most attention probability mass by this head is a token within the needle and is the same token as the currently generated token. The retrieval score represents a token level recall rate of the most attended tokens by an attention head. For example, a retrieval score of 0.9 indicates that the attention head has copied and pasted 9 out of 10 tokens in the target answer. The retrieval score is used to identify which attention heads are responsible for retrieving information accurately within the model.
What are the implications of the discovery of retrieval heads in long context modeling, according to the paper?
The discovery of retrieval heads in long context modeling has several implications according to the paper. Firstly, it marks a significant advancement in mechanistic interpretability by pinpointing a specific subnet responsible for implementing the conditional retrieval algorithm. Secondly, it explains why certain context compression methods fail to maintain factuality, as removing the retrieval heads results in a loss of the model's ability to accurately retrieve information. Thirdly, it suggests that future research on KV cache compression, a key issue in deploying long context models, should consider the influence of retrieval heads to reduce memory requirements significantly. Additionally, the presence of retrieval heads influences downstream tasks such as needle-in-a-haystack tests, extractive question answering, and chain-of-thought reasoning, where the model's performance heavily relies on the functionality of these retrieval heads. Furthermore, the paper highlights that retrieval heads are intrinsic to the base model due to large-scale pre-training, with subsequent training only making minor alterations to these head activation patterns. Lastly, the discovery of retrieval heads offers insights into the complex relationship between a model's retrieval and reasoning capabilities, indicating the importance of these heads in long context language modeling tasks.
How are the retrieval heads detected, and which properties are discussed in the paper regarding their nature?
The retrieval heads are detected in the paper by introducing a retrieval score, which measures the frequency of a head's copy-paste behavior during autoregressive decoding. The retrieval score is calculated for all attention heads under a diverse set of input contexts, using 3 sets of needle-in-a-haystack samples for each language model considered. The retrieval score represents a token-level recall rate of the most attended tokens by an attention head, with a threshold set at 0. 1. To identify retrieval heads. The properties discussed in the paper regarding the nature of retrieval heads include their universality and sparsity, their dynamic activation based on tokens and contexts, and their intrinsic presence in the base model as a result of large-scale pre-training. The paper also highlights that retrieval heads are responsible for information retrieval and implement a conditional copy-paste algorithm, playing a crucial role in the model's ability to accurately retrieve information from the input.
How do retrieval heads influence downstream tasks such as needle-in-a-haystack tests and extractive question answering?
Retrieval heads play a crucial role in influencing downstream tasks such as needle-in-a-haystack tests and extractive question answering. In needle-in-a-haystack tests, retrieval heads are responsible for accurately retrieving the required information from a long context. When retrieval heads are activated, the model faithfully reproduces the input document. However, if these heads are not activated or intentionally masked out, the model struggles to find the relevant information and may provide hallucinated responses instead. Masking out retrieval heads severely impacts the model's performance in needle-in-a-haystack tests, leading to incomplete retrieval, hallucinations, or wrong extractions. On the other hand, in extractive question-answering tasks, retrieval heads significantly influence the model's ability to extract information from the input context. Masking out retrieval heads results in a substantial decrease in performance, highlighting the reliance of real-world document QA tasks on the functionality of retrieval heads. Overall, retrieval heads are essential for accurate information retrieval and play a critical role in ensuring the model's factuality and performance in downstream tasks like needle-in-a-haystack tests and extractive question answering.
What are the potential applications and future research directions suggested based on the findings regarding retrieval heads in the paper?
The potential applications and future research directions suggested based on the findings regarding retrieval heads in the paper include 1. Mechanistic interpretability advancements. The discovery of retrieval heads marks a significant step forward in mechanistic interpretability in long-context language models. Future research could focus on further understanding and leveraging these retrieval heads to enhance model interpretability. 2. Improving context compression methods. The paper suggests that understanding the role of retrieval heads is crucial for maintaining factuality in long-context models. Future research could explore how to optimize context compression methods by considering the influence of retrieval heads, potentially leading to more effective compression techniques. 3. Deployment efficiency. The findings indicate that selectively pruning the KV cache corresponding to non-retrieval heads could significantly reduce the deployment cost of long-context models. Future research could delve into developing strategies to efficiently manage KV cache by leveraging the insights from retrieval heads. 4. Enhancing downstream task performance. Understanding the impact of retrieval heads on downstream tasks like question answering and reasoning can lead to improved model performance. Future research could focus on developing task-specific strategies that leverage retrieval heads to enhance performance in various applications. 5. Complex reasoning behaviors. The relationship between retrieval heads and chain of thought reasoning is highlighted in the paper. Future research could explore how retrieval heads influence complex reasoning tasks and delve deeper into understanding the interplay between retrieval mechanisms and reasoning capabilities in language models. 6. Algorithm discovery. The paper suggests that there may be more algorithms and functionalities implemented by different types of attention heads waiting to be discovered. Future research could focus on uncovering and understanding the diverse functionalities of attention heads in transformer models. 7. Efficiency in long-context modeling. Investigating the efficiency of different attention mechanisms like local linear attention and state space models compared to full attention could be a potential research direction. Understanding why full attention might be crucial for long, context information retrieval can lead to advancements in model efficiency. 8. KV cache compression. Future research could explore innovative approaches to KV cache compression based on the insights from retrieval heads. Developing efficient compression techniques that leverage the sparse nature of retrieval heads could significantly reduce memory requirements for long context models. 9. Interpretation of attention mechanisms. Further research could focus on interpreting the attention mechanisms in transformer models, particularly in relation to retrieval heads. Understanding how attention is utilized for information retrieval and reasoning can provide valuable insights for model development and optimization. 10. Model optimization. Leveraging the knowledge of retrieval heads could lead to optimized model architectures and training strategies. Future research could explore how to design models that effectively utilize retrieval heads for improved performance across various tasks and scenarios.